Today we use GPS even to go to the bakery. It tells us the way, calculates the route, avoids traffic, and even talks to us. All of that in the palm of our hand. But in 1969, humanity did something far more incredible. We went to the moon and came back. And believe it or not, without GPS, without the internet, and with a computer that had less processing power than your smartphone today. Sounds impossible, right? How did the scientists and engineers of the time manage to pull off such a complex mission using technologies we now consider almost primitive? In this video, we'll explore how the United States managed to send men to the moon with such limited resources, the key technologies they used, and most importantly, what this historic achievement still teaches us today. To understand how we got to the moon, we need to go back to the global landscape of the 1960s. The decade was marked by the Cold War, a period of political and ideological tension between the two biggest powers of the time, the United States and the Soviet Union. It wasn't just a race for weapons or political influence. It was also a technological competition to dominate space. It all started in 1957 when the Soviets launched Sputnik 1, the first artificial satellite in history. It was a wake-up call for the Americans who realized they were falling behind. Soon after, in 1961, the Soviet Union once again shocked the world by sending the first human into space, cosmonaut Yuri Gagarin. The message was clear. They were ahead. For the United States, this was unacceptable. The space race became a matter of national prestige, a way to prove scientific and technological superiority. That's when, in 1961, President John F. Kennedy made a bold statement. The United States would send a man to the moon and bring him back safely. And they would do it before the end of the decade. At the time, that promise seemed almost impossible. Technology was limited, and the challenge was enormous. But with a coordinated effort from NASA, engineers, scientists, and thousands of people working day and night, they turned this dream into reality. Reaching the moon wasn't just about science or exploration. It was a symbolic battle to prove who would dominate the future. And in 1969, with the Apollo 11 mission, the Americans finally claimed victory in this race. Beyond the geopolitical context, there was also the technological landscape of the time. In 1969, the world was very different from what we know today. Personal computers didn't exist. Most people couldn't even imagine that one day they would carry a compact and powerful device in their pockets. Back then, much of the scientific and technical work was done manually. NASA engineers performed complex calculations using paper, pencils, and in many cases, slide rules. Yes, slide rules, tools that seem almost ancient today, but were essential for running simulations and predicting trajectories. Electronic calculators were just starting to emerge, but they were out of reach for most people. They were expensive, huge, and extremely limited. To give you an idea, a basic calculator could cost the equivalent of several months' salary. Even with these limitations, the scientists of the time managed to develop innovative technologies and perform extremely precise calculations. And believe it or not, the computer used in the Apollo mission, considered a technological breakthrough at the time, had less processing power than a simple smartwatch today. Yet it played a crucial role in getting humans to the moon. Nowadays, we use GPS all the time, for driving, walking, or even finding a restaurant. But have you ever stopped to think about how GPS actually works? It's a global positioning system that relies on signals sent by a constellation of satellites orbiting the Earth. Your device receives these signals, calculates how long they took to reach you, and based on that, determines your exact position in terms of latitude, longitude, and altitude. But here's the catch. In 1969, when the astronauts went to the moon, GPS didn't exist. The GPS system only started development in the 1970s and wasn't fully operational until decades later. So how did Apollo 11 navigate through space without this technology? The answer lies in a combination of precise calculations, navigation technology based on predefined trajectories, and surprisingly, using the stars as a guide, much like the techniques ancient sailors used here on Earth. Just as early navigators crossed the oceans by relying on the stars for orientation, the Apollo crew used an optical sextant to align the spacecraft in space. The Apollo sextant worked very similarly to a maritime sextant. It allowed astronauts to measure the angles between specific stars and a reference horizon, which in this case could be the Earth, the Moon, or even an imaginary line in space. But here's the interesting part. they didn't do it alone. The Apollo Guidance Computer, or AGC, had a catalog of star positions that served as fixed reference points. When the astronauts used the sextant to observe these stars and measure angles, they fed the data into the AGC. The computer then recalculated the spacecraft's position and adjusted its trajectory if needed. This method was extremely precise but required skill and training. In space, the stars don't twinkle like they do on Earth due to the lack of atmosphere. So astronauts had to identify the right stars in a pitch-black sky filled with countless points of light. The use of the optical sextant combined simple yet effective technology with astronomical knowledge in the power of the onboard computer. It was an ingenious solution that allowed them to navigate through the vastness of space using nothing but the stars. Something that, in a way, connected space exploration to the age of great maritime voyages here on Earth. The lunar expedition also relied on what was called the inertial navigation system. Essentially, it used mechanical gyroscopes and accelerometers to measure the spacecraft's position and direction in space. The gyroscopes were responsible for detecting any changes in the spacecraft's orientation. They ensured that the system could determine whether the spacecraft was tilting, rotating, or changing direction. Meanwhile, the accelerometers measured changes in velocity. In other words, the spacecraft's acceleration. In space, without visual references or friction, you can't feel whether you're speeding up or slowing down. That's why the accelerometers were crucial for precisely calculating how much the spacecraft had moved over time. But even with these advanced sensors for the time, there was a challenge. The collected data needed to be processed quickly to adjust the spacecraft's trajectory. That's where the onboard computer we mentioned earlier, the AGC, came in. It received data from the gyroscopes and accelerometers and calculated in real time where the spacecraft was and where it was headed. It performed the complex calculations necessary for navigation, turning sensor data into clear instructions for the astronauts. It was the perfect combination of mechanical ingenuity, precise sensors, and the limited but crucial power of onboard computers. And thanks to these systems, Apollo 11 was able to hit its path to the moon with the precision required. Another crucial factor in the mission was maintaining contact with Earth. The technology that made this possible was radio signals. Even in space, Apollo 11 was able to send and receive data, commands, and even audio and video transmissions, all through radio waves. The antennas on the spacecraft were responsible for transmitting signals that traveled over 238,000 miles between Earth and the Moon. The signal took about 1.3 seconds to cover that distance, creating a slight delay in communication. Still, it remained stable and reliable. To ensure everything worked smoothly, NASA relied on the Deep Space Network, a system of massive antennas spread across the globe. These antennas captured the faint signals from Apollo, amplified them, and decoded the information for scientists and engineers at Mission Control. Thanks to this system, the crew and NASA's team on Earth were able to stay in constant communication, monitoring the spacecraft and ensuring that any issues could be quickly corrected. Radio communication was a simple, efficient, and essential solution for the success of the mission. Last but not least, there were the redundancy systems. Just like in airplanes, engineers knew that any failure could be fatal. That's why they adopted the concept of redundancy. Essentially, every critical system had a backup. For example, electrical systems, navigation systems, and even the onboard computers had duplicate versions or alternative plans. If something failed, like a motor or an electrical circuit, a secondary system would automatically take over. This significantly increased the chances of mission success. A famous example of this was the moon landing. When the Apollo guidance computer started experiencing overload errors, the software prioritized critical tasks and discarded the rest. Thanks to this logical redundancy, the mission continued without interruptions. Additionally, the astronauts were trained to perform manual maneuvers in case automated systems failed. They knew how to operate the spacecraft by hand if necessary. This shows that the combination of advanced technology and contingency plans was crucial to Apollo 11's success. The redundancy systems acted like a safety net, ensuring that even if something went wrong, the astronauts had an alternative way to complete the mission and return home safely. Going to the moon was more than just a milestone in space exploration. It was a true testament to human ingenuity. Despite the technological limitations of the time, engineers, scientists, and astronauts worked together to achieve the impossible. They proved that with creativity, planning, and courage, There are no limits to what humanity can accomplish. Now here's something to think about. If more than 50 years ago we managed to land on the moon with so little, imagine what we can achieve today with modern technology, quantum computers, artificial intelligence, and reusable rockets. Will we be returning to the moon soon? Or will we take an even bigger leap and set foot on Mars? Now I want to hear from you. What do you find most impressive about this story? The precision of the calculations, the simplicity of the solutions, or the sheer bravery of the astronauts? Drop a comment and let me know what surprised you the most. And tell me, do you think we'll return to the moon with the same boldness as in 1969? Or is the next great leap taking us even farther? Let's talk about it.